Stories. They are great, aren't they? Everybody loves a good story. And I'm here today to tell you a story as well. The story of how we brought complex animations to AMP. So here we go. Once upon a time, right before lunch, but after a munch, just before a merge, but after a purge, Ali G got a message. This is cool. Can we do it in AMP? Of course we can, said the little man. Give me a minute. I shall be back. By the way, this is the only cheesy part of the presentation, so do not worry. Optimism is great, isn't it? So 1 year later, we were done. But a lot more than just Parallax was done in that year. A low-level framework was created to handle many complex animations in AMP. So let's take a step back and look at that journey to talk about the 3 different approaches we took, the complexities, the trade-offs, and of course, the final results. But let's start with the basics first. So what is Parallax anyway? At its core, it's just some content moving faster or slower than the other content as the user scrolls. You have likely seen this in one form or another on the web. But why is it a hard problem? Isn't CSS meant for this sort of thing? Well, like many other things in the web platform, there is no primitive for Parallax. But there are many other primitives which can be hacked together in innovative ways to create new things. And that's one of the beauties of the web platform. So let's talk about the first hack we tried. It has something to do with 3D support in CSS. Perspective is a property in CSS that creates a 3D space by moving the viewpoint out of the 2D pane and into the 3rd dimension. The value of the property, of course there will be cats. The value of the property is essentially the distance that controls the intensity of the effect. So in this example, that's not showing up. It was showing the use of the Parallax, use of the perspective property in CSS. So as the viewpoint, as you use the perspective property, as you change the viewpoint, and as you get closer to 3D things, you notice more 3D-ness. And as you get further away, you notice less. So what does that have to do with Parallax? Bear with me for a minute, and I will explain how 3D CSS has anything to do with Parallax. Another property of 3D CSS is that browsers were very serious about this virtual world mimicking the real world. So just like in real life, distant objects seem to move slower than the closer ones as the viewpoint moves across. The classic example of this is looking out of the window of a moving train. The mountains seem to move slower than the trees, and so on. But whatever, how is this related to Parallax again? Well, scrolling is the movement of the viewpoint on the y-axis. So if we create multiple layers on the z-axis at different distances from each other, they will move slower or faster relative to each other as the user scrolls. Of course, the distant objects are also rendered smaller than their intrinsic size. Again, browsers are being super realistic here. But what we can do is to scale them back to their original size, so the only varying speeds are observed, therefore creating a parallax effect, such as the one you see here. All right, great, easy, parallax done, right? Well, WebKit on iOS cannot do both momentum scrolling and create a 3D space at the same time. It simply flattens the 3D space as soon as it sees overflow scrolling touch. And momentum scrolling is the good kind. That's the one you want. It's somewhat a known bug. It has been reported a few times, and unfortunately, there is no fix in progress for it. There are some workarounds, but they are not perfect, and require some markup restrictions on the markup that are not acceptable in AMP. For instance, the scroller element cannot be the body element, and the parallax element has to have position sticky. So these are not things we can do in AMP. If you're still curious about this approach and the genius but very complicated workaround for Safari, please see this awesome blog post by the Google developer group. You can find it by just Googling performance parallaxing. All right, so what's the next trick to try? Well, what if you pull or push an element as the user scrolls? User scrolls 6 pixels. We add 3 more pixels, so it moves faster. This can be done via CSS transform, which is hardware accelerated, so that's great. We still need to debounce the scroll events and hit a good balance for smoothness and handle some edge cases, but it's doable. Well, some of you may notice we actually did this. We launched an experimental component called AmpFX Parallax a while back based on this approach. So what was the problem? Why didn't it launch? Well, essentially, it overpromised and underdelivered. It could not handle complex parallax scenes, and parallax is just a small subset of what developers wanted to do with the scroll-bound animations on their pages. We needed a more generic and powerful approach that could handle parallax, but a lot more. In hindsight, we could have polished and launched the experimental component while working on a more comprehensive solution. But in my defense, I also thought the new solution would only take 5 minutes too. So what did we end up doing? So here's an idea. Keyframe animations can create very complex effects. So what if we sync the timeline of an animation with the position of an element within the viewport? Essentially, tick the animation with a scroll instead of time. Here's what I mean. Here we have 2 examples. They're using the exact same animation code, but they just are ticked differently. The first one goes through its animation timeline with time. That's how animations normally work. The other one goes through its animation timeline as the clock moves across the viewport. But how do you do parallax with keyframe animations? Well, if at the end of the animation timeline, an element is requested to be above or below where it's supposed to be, it must move faster or slower to get there. In this example, in normal situation, the rocket will be at the top of the viewport after the user scrolls 1 viewport amount of scrolling. That just makes sense. You scroll 1 viewport amount, and it will be on top of the viewport. But with the animation definition, we are asking it to be half a viewport, the 50 VH here, more on top. So it has to move faster to catch up, to get to its final state that we are asking. So that's how you do parallax with keyframe animations. We have launched this solution under 2 independent but related components. AMP animation can be used to define your effect. An AMP position observer can be used to sync an animation timeline with a scroll, or more precisely, with the position of an element within the viewport, because that's easier to reason about than an absolute pixel value of a scroll top, for instance. But before we get into the details of how you can use these components and what their API looks like, let's first see what you can do with them. Of course, you can spin a fidget spinner. That was the MVP. But what else can you do? Maybe you want to have opacity of an image to be tied with a scroll. Or maybe not a scroll, but you want an image to fade in when it comes into the viewport. Or maybe when it comes to the view in the middle of the viewport, for instance. Or both. You can mix visibility-based, time-bound animations with scroll-on animations to create effects like this. How about an image window, or more precisely, a parallax image window? You can use these components on any element, whether a normal HTML element or an AMP custom element. Here we have an AMP carousel that slides in the first time it becomes visible in the viewport, and after that, it just behaves like a normal carousel. It may not be obvious at first, but these building blocks can be used to create useful features that are not just some fancy visual effects. For example, you can have headers that shrink or expand or hide and show when the user scrolls a little bit off top of the page. Similarly, you can show a scroll to top button that only becomes visible when the user has scrolled past a certain threshold. You can even implement a snack bar overlay with it. This is not possible with pure CSS. We tried. You can probably do it with AMP bind and CSS, but hey, here's another way to do it. And of course, you can do all of this without writing a single line of JavaScript. Now let's get into the details of the underlying components that were used to create these demos. AMP animation is a wrapper for Web Animation API. But it also adds many new useful features to it. For instance, it adds variables. It adds conditional animations based on media queries or support matrix. It allows for composition of animations. And it adds useful functions such as calc, random, or ability to measure width and height of other elements and use those values in your animation definition. The component also exposes actions such as start, restart, pause, and seek to, which can be used to manipulate the running state of the animation. AMP Position Observer is a functional component that simply monitors the position of an element within the viewport. And it dispatches enter, scroll, and exit events as an element moves through the viewport. These events are considered low trust, which means you cannot run many AMP actions as a result of these events. You can only run other low trust actions. And the actions exposed by AMP animation component are also low trust. And a few actions exposed by our video players are also considered low trust. So you can run those. The API is fairly similar to the native intersection observer. And attributes such as intersection ratios and viewport margins can be used to change the behavior of these functional components. So now let's see how these two work together to spin a fidget spinner. Well, first, we define our animation. It's fairly simple. We find the fidget spinner image, and we take it from 0 degrees to 360 degrees. So that's the definition here. Next, we have to define our scene, our animation scene, which is simply an image, but also a position observer to monitor the position of the image within the viewport. Here we are using intersection ratio 1, which means the effect only comes, you only see the effect when the fidget spinner is fully visible. Had we chosen to put 0.5 here, for instance, the fidget spinner would have started spinning when it became half visible and would have stopped when it became half invisible. And this is really where the magic happens. This is where we sync the animation timeline with the scroll, with the position of the fidget spinner within the viewport. So at the beginning, when the image of the fidget spinner is at the bottom of the viewport, the scroll event starts dispatching the value, a number between 0 and 100, the percentage of where it is within the timeline. So you start at 0, goes up 1%, 2%, 3%. When it gets to the middle of the viewport, it would say, I'm at 50% progress. I'm in the middle of the viewport. And as we get those events, we tell the animation timeline to also seek to its position of 1%, 2%, and 50%. And 50% happens to be 180 degrees, for example. And when we get to the top, we are both at 100%, and the animation will be at its end, and it would have done a full rotation. Abstraction based on simple rules can be very powerful. Allowing syncing of animation timeline with any other timeline opens up other opportunities. For example, you can sync a video timeline with an animation timeline, creating overlays that are perfectly time-synced on top of your videos. And you can do this today. And the idea is the same. As the video goes through its timeline, it reports progress. I'm at 10%. And we ask the animation to be at 10%. And the animation is showing the overlays at those positions within its timeline. And of course, there are other opportunities. Basically, anything that can progress, anything that can go from 0 to 100, can be made to sync with anything else that can progress and go from 0 to 100. For instance, we can start syncing animation timeline with an AJAX request, with the status of a network request. Or we can actually try to sync a video timeline with a scroll, same way we did with animations. So we have a scroll-bound animations. Why not have a scroll-bound videos? We actually tried this, and unfortunately, all browsers are very, very slow at syncing to a particular frame within the video. So the overall scroll-bound video was not a smooth experience at all. A particularly exciting one that we are planning to launch soon is ability to sync an animation timeline with the physical tilt of a phone. Imagine you could configure what 0% and 100% marks are based on a degree a phone is tilted on a particular axis. Now, there are 3 of them, and you can have 3 animations for each, and effectively creating complex visual effects such as 3D parallax. So look out for that in the near future. So, are we done? Well, now we have the building blocks that cover many use cases, but they come at a cost. For simple cases, they're simply too verbose and not very simple to use. And ease of use is something that we value in AMP. Therefore, we are bringing some common visual effects. Although they're already possible with the existing building blocks that we talked about, to AMP under an easy-to-use API, under a new extension called AMP Effects Collection. And the very first effect that we are adding to this collection, going full circle, is Parallax, which you can use today. But we are planning to add more, things such as a slide in, fade in, and so on. Here you can see the new Parallax API in practice. The behavior is similar to the AMP Effects Parallax, which is now removed, but the names and the syntax are a bit different to allow for expansion and composition of the effects. So here, essentially, we are saying we have an AMP image, and we want the parallax effect on it. We are controlling how the effect works using the parallax factor. If the factor is greater than 1, it's going to move faster as the user scrolls, and if it's less than 1, it will move slower. Now let's talk about some of the boring stuff for a bit, about the challenges we ran into and the optimizations we did. While building these features, we have made sure that they are not only very performant, but in true spirit of AMP, they cannot be used in a slow way at all. we all want 60 frames per second. That means when using AMP animation, we had to whitelist only certain properties that are hardware accelerated and blacklist all the other ones. This means when you're using AMP animation, you can essentially only animate transform, opacity, and visibility, and nothing else, because those are the ones that are hardware accelerated. This may restrict you on what you can do, but at the end of the day, your UX will be better, and your users will be happier. Viewport is another challenge we ran into. In the eyes of the browser, there is no single viewport. When things are in an iframe, everything is relative to that sandbox window. But we want the position of an element in the real viewport, the one that the user is actually looking at. So we actually collect information from different layers of these viewpoints, and we coalesce them together to get the final result for the viewport that the user is looking at. And this is important for AMP, because AMP is a portable content format. It can be in cross-origin iframes, same origin iframes, shadow DOM, and of course, as a top-level document. Web Animation API itself is a fairly new API, and not all the browsers support it. And the ones that do have partial support a lot of times. So we have researched and found a good polyfill for web animations that's included in the AMP animation components. But finally, and most importantly, animations are not transitions. Animations go from a known state, from a known first keyframe to a known last keyframe. But transitions go from the current state, whatever that might be, it's not known ahead of time, to a final state. So unlike web animations and unlike CSS animations, AMP animation does not require you to provide a first keyframe. And if you don't, we will calculate that for you. This single feature alone provides significant flexibility on what you can do with AMP animations in terms of creating actual transitions. Building this has been a big team effort, and on behalf of everyone involved, I hope you find these features useful, and we can't wait to see what you build with them. Thank you.